Hello everyone, I'm Ms. Kanau, one of your grade 11 maths teachers. In our previous lesson, we looked at logarithm and its properties. We will continue with logarithm in today's lesson. Logarithm. And we'd look at properties. There were three basic properties we looked at when I introduced that on properties. The first was the product property, the second was the quotient, and the third was the power. Let's continue on to the fourth property. In property number 4, we have log base b 1 is equal to 0. If we were to understand it in an exponential way, it would actually be base b to the power of 0 is equal to 1. That simply means that any number at all in the counting system that is raised to the power of 0, of course excluding 0, is equal to 1. If that is correct in there, let's see an example. And the example is log base 2 1 is equal to 0. If I were to write it in this form, b is the base, which is 2. The power is 0, and the result is 1. So any number at all, be it 1,000, if it is raised to the power of 0, its value will always equal to 1. Let's continue with the next property and call it property 5. In property 5, we have log base b is equal to 1. That looks funny. We've got log base b 1 is equal to 0. This time we have log base b is equal to 1, which means that log base b is the same value as this b here. Its value is 1. If we wish to understand it better, we would say that, okay, that would give me to the base is b, the power is 1, and the value is b. That simply tells us that any number at all in the counting system that is raised to the power of 1 is always equal to that number. Let's look at an example. If I have log base 10 of 10 is equal to 1, it simply means 10 to the power of 1 is equal to 10. So the value of b is 10. Log base 10 is equal to 1. 10 to the power of 1 is equal to 1. If I have 1 million raised to the power of 1, the value is still 1 million. Let's look at another example of properties. Now, there are many properties in logarithm, but we'd only look at some. In that case, we call it property 6. In property 6, we have log base b to the power of n is equal to n. To make us see it clearer, we would write it as n log base b is equal to n. Right. If we have n log base b is equal to n, let's look at an example here. We look at an example here, it would give us 2 log base 10 to the power of 3 is equal to 3. If that is correct, then we use the power property and have it written as 3 log base 10 is equal to 3. But note, 3 log base 10 is the same as having log b, which is equal to 1. So if that is correct, that terminates, and we have 3 is equal to 3. Now, having looked at these properties, let's try to apply the properties that we have looked at into actually solving an expression. And if that is correct, let's have an example over here. If that is an example, it would give us 2 log base 2, all of that is equal to 128 multiply 64 all over a denominator of 8 multiply 16, all of that raised to the power of 5. If we have log base 2 brackets 128 multiply 64 all divided by 8 multiply 16, all of that raised to the power of 5, we could then simplify by expanding, and we would go, omit the log sign outside. When that is done, we would have log base 2, 128, all of that. Multiplication becomes addition, and we have log base 2, 64, all divided by log base 2, 8, adding that onto log base 2, 16. Note, it is still in the brackets, and it is raised to the power of 5. Simplifying that, we then have log as the coefficient and put it outside the brackets, and that would give us to 5. Inside, let's simplify. 128 base 2. How many times can we multiply? How many times can we multiply 2 by itself to give us a product of 128? Yes, it is 2 raised to the power of 7. Adding that onto, how many times could we multiply 2 by itself to give us 64? The answer is 6. So if we multiply 2 by itself 6 times, it gives us 64. Divide. Okay, a property says that when you're dividing, it becomes a subtraction. That is the quotient property. So that gives us 2 minus, how many times can we multiply 2 by itself to give us 8? The answer is 2 to the power of 3. And that would give us 2 minus, again, because we're dividing, 16 base 2, you multiply 2 by itself 4 times, and it gives you 16. Now, note you have the 5. It means that the 5 will be multiplied by the result of 2 to the power of 7, 6 plus 2 to the power of 6, minus 2 to the power of 3, minus 2 to the power of 4, and the answer would be 7 minus 3 minus 4 is 0. You're left with 6. When that process is done, note that goes off, that goes off, that goes off, and that goes off, and you just deal with the powers. Your result then would give you the product of 5 and 6 gives you 30. And that ends our lesson on properties of logarithm. In our next lesson, we will still be looking at logarithm, but this time we would be solving equations or logarithm equations. I hope you have enjoyed today's lesson. I'll see you later.